All right. Yeah. So talked a little bit off screen, but really what I want to show is anytime we are doing anything on the web, here we have no network activity. If I refresh this page, the very first thing we get back is HTML after that cookie goes away, and it already knows I'm Greg. And the reason it knows I'm Greg is because we're sending headers. Let's see if we can't find, here we go. This is what's telling me. This is what's telling the computer that I'm Greg, is my cookie. Your cookie is a little tiny string, essentially, that you save on your computer that is localized in particular to yourself. And so sessions are what we web developers call when these cookies match up with our database. So if I have cookie A and the database has a user associated with cookie A, and I log in, it knows that the user of cookie A is currently in a session. So that's why we see this word session here, and that's why we're seeing forge, because it's creating this session using my set cookie that I'm sending to the server that they've decided to name Cowboy, and we're getting back all of this additional information in addition to how we have set the cookie and how we sent the cookie to the server. It says HTTP only. I can't see the whole path. Let's try to do HTTPS. Still works. Cool. Now the question is if it's actually HTTPS. It is. Cool. So if this server didn't support HTTPS, this would actually error out. So that's why I have this browser extension up here, HTTPS everywhere. It forces your browser to try HTTPS first because it's safer and it's a secure network where you do a handshake with the server and collectively agree that you can only decode each other's messages if you have a specific set of information that you exchange using hashing algorithms. It sounds very complicated, but really the way it works is there's 4 images for all you need to be concerned with. 2 of those images are publicly available and 2 of them are not. And we have 2 of those images and the server has 2 of those images. So we have our public image and the server has its public image. So when we go to a server, we take its public image and we download it onto our computer, and we take our hidden image, the one that's not available online, and we say, encode this public key with our hidden, so I said key, it's an image, it's a hash string, it's data. Encode this key with the public key that we have, and so that way the server knows that it's us, but it knows that this data could only ever come from us because we have this hidden file that nobody else has access to that corresponds with this public key. If you want to look into this more, a really good one is GPG. So this is essentially the way HTTPS works, is we have a public key and we have a private key. When we hit an HTTPS server, we grab that public key, we encode our message, including our private key, and then we send that off to the server that only the server can decrypt because only the server has the private key. Nobody else can decrypt the message intended for the server because nobody else has that private key. If the private key was ever exposed and compromised, they would create a new hash and create 2 new keys where now there's a new public key and there's a new private key that are completely and totally separate from the other ones. And again, this is based on SHA-256, so if you were to try and crack exactly what the cookie is from the public key, it would take you years to do this. So it's one of those things where it's like you would need to be so inspired to try and break into this system of the public and private keys that you would need to have like again, like governmental bodies or like rogue agents operating inside of your network where they're conspiring against you using resources and like corresponding and colluding with each other to come to that goal. Like you're never going to find like a solo hacker who is going to try and leverage these technologies against you unless you are extremely careless and you're just like pasting your password online, because then that's easy, right? It's a low-hanging fruit. But if you're using HTTPS and you're using, you're not copying and pasting your password in places you shouldn't, you're going to be safe 99.999% of the time. It's when that 0.0001% of the time that you're not secure, we have these sorts of technologies to help us ensure that there's another level of security beyond just sending plain text between passwords, servers. So if you wanted to look into what I'm talking about a little bit more, you can look into like PGP keys. PGP key generator, cool. What else? Here we go. My email address. Okie dokie artichoke at at fun.com. Passphrase, no. Is it gonna email it to me? Do I have to actually go on my email? Why do you have these things here? Gosh darn it. Well, sorry whoever has that email. Just sent you a bunch of PGP keys. Gosh darn it. Okay. Gregory.Baca. Oh, there we go. Cool. So it was just running in the background. This is what it looks like. So everyone knows our public key. This is something that we want to share with people so they can talk to us. So this is kind of like your phone number on the right. And this is what every server is using in HTTPS. So on the right, we have this hashed string. And we say, hey, this is my phone number. If you want to hit me up, run this hash string. So the server will take this. It will hash this string with its own private hash string. And then it will input its own private key inside of that hash. And then it will send it to us. And it will say, hey, if you get this message, then use it so that way I know this is you specifically. And I know that you're the only one that can decode this message. And so that's how this works, HTTPS, is we have this public and private key system where we are allowed to share our public key with everyone, but only we know the result of hashing the result of this private key. So that's how we're able to have secure web communication with HTTPS, is using public and private keys. You guys don't really need to know that, but there's a fun little aside. So generally, if you're just doing HTTP, everything that you send is in plain text, like period, even your password. So like right here, if I did like greg.com and password, if this is not HTTPS, if this is just HTTP, when I hit enter, it's going to say this user's email address is greg.com. This user's password is password. And anybody that wants to look at that file as it's on its way to the server can just open that file, like literally, if they can connect to the route that you're hitting, because you're never going to just have a direct connection to Google servers. Like you have to hit your ISP's route and then like their routing. You have to bounce between relays. You don't just go straight to wherever you're going every single time, right? Like if you want to go to the store, you don't just walk out the door and you're at the store. You have to go out the door, you have to get in your car, you have to go down the street, right? There's like a process that has to happen. And that's the same thing with servers, is there's a process that has to happen for the data to go from your local machine to the remote server online. And so if you're sending a plain text HTTP request, you're sending all of your information unencoded and just plain text, like literally anybody could just open this packet and they would see that what I typed in is greg.com and password and it would actually have it specifically ordered in this way, like this, where it would say the user's email is get and their password is 200. Like That's how easy it is to intercept people's passwords if you're not using HTTPS. So to bring this all home, that's why I'm using this extension, and that's why there's a differentiation between HTTP and HTTPS, because HTTPS stands for HTTP secure, and it's just hashed. And so now if I was to intercept this message, instead of getting this plain text, hey, here's all of my information, I get that horrible, ugly public key that only the server can decode because only that server has its private key. So if you're like super paranoid about your data, now might be a good time to download this HTTPS everywhere. App, plugin, whatever, but you don't have to. All of your data generally is very, very safe online, unless, again, you're like copying and pasting your password onto forums. Hopefully I don't need to explain why that's not safe. But generally, we're all okay. If you think about the amount of times you have gone to all these websites and not use HTTPS and you're still fine, like, generally we're going to be okay, right? Like, your entire life, you might not have realized it, you've been sending your password in plain text over your network your entire life. And like, how many problems have we had? Like, not a lot, right? So this isn't a horrible problem, but now you kind of understand like why we have the difference between HTTPS and HTTP, like what HTTP is. It's just like a communication protocol, and it's really just text at the end of the day. This is HTTP right here. This is HTTP. Now we don't see it, but these are the headers, and then we're also getting a body. So the body would look like something inside of our preview. We get this weird looking SVG. Oh, that's a GIF rather. But if we reload the page while we're actually recording, and we preview this, there we go. So instead of reading my password, a hacker would have to try and unhash this string if they wanted to try and log in as me, right? All of a sudden this becomes a lot harder just because we're using HTTPS. So if we're sending HTTP, here's the header, here's the HTTP header, and then here's the HTTP body. And those are like essentially the two pieces of the entire World Web that make the web work. You have headers and you say, this is what I'm looking for, this is the person that I am, this is the thing that I'm doing, this is the date that it happened. Like, this is kind of like the what, the how, and the what, but this is like the result of your actions of your header, to put it like very, very plainly. But this is all HTTP protocol, and that's what we're doing when we are going to something like google.com. Our browser is creating an HTTP request. It's going to the URL Google. The method is get, and it's going to be 200. Oops. Gosh darn it. This is why you shouldn't have a million tabs open. Where was I? Okay. Huh? Oh. All right, I'm sorry. Okay. Google.com. Now, if we watch on this right side, we get all the network communication, and we get the status code right here, 200. Just like I said, we're using HTTPS because of my network extension. My plugin right here. We're going to Google. We're doing a get method. The server says this is a valid response. This is a valid method. I'm allowing this user to do this. This is the remote address that we're hitting, and a refer policy that is some technical jargon that we don't need to get into. And then in addition to that, we have an alternate SVC in case maybe the Google thingamabobber doesn't load, a cache control. So this is in relation to our cookies, so on and so forth, right? Your browser's doing this automatically every single time you're going to any single web page. And here's our cookie. And this is telling Google that I'm Greg, and that's how they're able to track me and serve me ads that are pertinent to everything that they're recording me say. That's why you hear people say delete your cookies, because these are what they use to track you with. There you go. So that's HTML, that's CSS, and that's DOM. Very high level, going into all of that all over again. So if we go into everybody's grades, I'll cut that out, as a matter of fact.